Good afternoon, morning, some time of day anyway. This video is the second of three videos on section 1.5 in your textbook entitled Analyzing Graphs of Functions. So, the first thing that we're going to talk about today is essentially the slope of a function, okay? And so an increasing function is one that on an interval for 2 points, a positive change in the value of x results in a positive change in a value of f of x or y. So if you look at a graph, right, as x goes up, y goes up. And so you end up with a function that has a positive slope, okay? Seems reasonable enough, right? So read that again. On an interval for 2 points, a positive change in x, meaning that we're moving to the right, results in a positive change in f of x, meaning that we're moving up, all right, which gives us a function with a positive slope. On the other hand, a decreasing function is not just the opposite, but on an interval for 2 points, a positive change in x, all right, so moving in the positive direction toward the right, results in a negative change for f of x. So we're moving down in the y-axis, and that would look something like this. All right, that would be a decreasing function. And then finally, a constant function is one that on an interval for 2 points, a positive change in x results in no change, a zero change in y. And so that might look like this, all right? Simply a flat line, and that we would call a constant function. All right, and if you think about it, that's really those are really only the only three slopes rather that a graph could have. It could have a positive slope, a negative slope, or no slope, right? That's what our options are here. So let's have a look at example number 4. All right, use the graphs to describe the increasing, decreasing, or constant behaviors of the functions. Okay, so I've given you 3 different possibilities here. The first one is f of x equals x cubed. The second is f of x equals x cubed minus 3x. And the third is a piecewise function where if x is less than 0, meaning that it's a negative number, we use f of x equals x plus 1. If x is equal to 0, less than or equal to 0, or less than or equal to positive 2, we use the function f of x equals 1. And then finally, if x is greater than positive 2, we use the function negative x plus 3. All right? And so those are the 3 choices. Now, for the next 3 slides, I'm going to show you a graph of each of these 3 functions, and we're going to describe the increasing, decreasing, or constant behavior of those functions. All right? So this is the graph of f of x equals x cubed. And you can see that no matter where we look here on this entire graph, we find that this is an increasing function. There's no spots where it's constant, all right? At least not between 2 or more points, all right? It might be perfectly flat right here at the point 0, 0, but that's only 1 point, not multiple points, all right? And so through this entire graph, we've got an increasing function, all right? That was easy peasy, I hope. Okay. Now, for the function f of x equals x cubed minus 3x, we have a different scenario here. They're between negative infinity, and this point, and I'll draw a dotted line here, right? Over here, we are increasing between this point and this point. We are decreasing and then from here to infinity, we are increasing again. All right, and so there are literally three distinct portions of this graph. All right, and so how do we define this? Well, here we start with negative infinity. I've never tried to draw an infinity. Darn it. Nope. Negative infinity to this point is -1. All right, and so from negative infinity to -1, we're increasing. Here, from -1 to 1, we are decreasing. And then here, from 1 to positive infinity, we are increasing. Okay. All right. Three separate portions of the graph, and different things are happening in each of the three portions. All right, we're increasing from negative infinity to -1. We're decreasing from -1 to +1. And then we are increasing again from +1 to infinity. Now, the third example gives us a bit of trouble. And I couldn't get GraphSketch to actually draw this, but we know that if x is less than 0, we're going to use the formula x plus 1. So if x is -2, y is -1. If x is -1, y is going to be 0. If x is 0, well, if x is less than 0, x is, y is going to be a value of 1. So the first portion of the graph is going to look like this. Okay. Now, between 0 and +2, the value of f of x is 1. And so we're going to run all the way across to here. And then from when x is greater than 2, it's going to be the value of f of x is -x plus 3. So if x, for example, is 3, then -x plus 3 is going to be 0. And so we're going to have, starting here to this point, if x is 4, then -4 plus 3 is -1. All right, and so my graph is going to go down. All right, so again now I have three distinct portions of this picture here. All right, in this portion, whoops, I've got an increasing value, and this is sorry, increasing, and this of course is going to run from negative infinity all the way up to x x equals 0. Then it's going to be constant between the values of x equals 0 and x equals 2. And then over yonder, it's going to be decreasing from x equals 2 to x equals positive infinity. Okay, and so those are our descriptions of whether this thing is increasing, decreasing, or constant. Okay? All right. So that then leads us to the idea of extrema. And an extrema is either a maximum value or a minimum value. And here we're talking about the y values. All right. In other words, the highest height on a graph or the lowest low, the lowest valley on a graph. And there's 4 different kinds of extrema. You have local maxima, or a local maximum, which is a value of f of c that is greater than or equal to all range values on some open interval containing the value x equals c. All right. So in other words, it's the highest height of a hill on a graph. Now, an absolute maximum is a value of f of c that is greater than or equal to all range values of f. In other words, the highest hill on the graph. A local minimum is a value of f of c that is less than or equal to all range values on some open interval containing the value c, so the lowest point in a valley. And the absolute minimum is a value of f of c that is less than or equal to all range values of f. So in other words, the lowest value that there is. All right. And so in these cases, essentially what we're doing is we're simply looking for the apex, the top, or the bottom of a hill or a valley on a graph. All right. And whether it's a graph that contains multiple minima and maxima or just one, it doesn't really matter. That's what we're defining here, the maxima or the minima. Okay, and they can be, the maxima are the highest heights, and they can be local or absolute, and the minima are the lowest lows, and they can again be local or absolute. So let's have a look at example number 5 here. All right, using a graphing utility, or use a graphing utility to approximate the relative minimum of the function f of x equals 3x squared minus 4x minus 2. Okay, and so in this case, what we're going to do is graph this function and then determine where the lowest low actually is. All right. So in this case, let's go ahead and graph it. And if again, I used graphsketch.com here to find out what the lowest low value actually is. Now, and this is the graph that I got. There's a couple of different ways that you can approach this, all right? But obviously, this point right here is the lowest minimum, all right? And so this is not only a local minimum, but it's also an absolute minimum. If you have a graphing calculator, a TI-84 or a TI-89, you can graph this, and it will actually give you the minimum here. Graph Sketch, there are ways to do this. I'm not going to get too crazy with this at this point, but on a TI-84, if you look at this, you'll find that the lowest value is the point 0.67, comma, 3, negative rather, 3.33. All right, so this is negative 3.33 on the y-axis, and this is 2/3 or 0.67 on the y-axis. All right, and if you find this point, that's what you end up finding. All right, so there's the point right there. All right, 0.67 or 2/3 minus 3.33 or 3 1/3. Okay, and those are the values x and y that give you the local or absolute minimum of f of x equals 3x squared minus 4x minus 2. Okay. Now, For our next trick, what I'd like to do is go through the, actually, do I want to do this? You know what? I think, yeah, we'll go through average rate of change. Why not? The average rate of change for a nonlinear graph whose slope changes at each point, right? Because anytime you're looking at a curve, the slope is not constant. So for a nonlinear graph whose slope changes at each point, the average rate of change between any 2 points is the slope of the line through the 2 points. And so we use the slope formula, right? This is really y2 minus y1 divided by x2 minus x1, right? That's the slope formula. And that gives you what we call the average rate of change for the graph of a function. Okay, so keep that, that formula in mind. And let's have a look at the graph of f of x equals x squared as an example. Okay, the blue curve represents f of x equals x squared. And so what I do here is I find 2 points, all right, between 0, 0, which is down here. All right, this is 0, 0 here. And this is the point 2, 4 here. Now, if I want to know the average rate of change, it's going to be f of, well, it's going to be 4 minus 0 as my change in y value over 2 minus 0 for my change in x value, right? That's what slope is, right? Delta y over, come on, delta x. All right, and 4 minus 0 is 4, 2 minus 0 is 2, and 4 divided by 2 is 2. All right, and again, this is really just the slope of the line that connects the 2 points that we're talking about here. Okay, so how do we use this in a problem? All right, well, here in example number 6, you're asked to find the average rates of change of the graph of f of x equals x cubed minus 3x from the point x equals negative 2 to the point x equals negative 1, and from the point x equals 0 to the point x equals 1. All right, now we've already seen the graph of x cubed minus 3x in one of the earlier examples. Now we're not going to be worried about anything but finding out what the average rate of change is from x is negative 2 to x is negative 1, and from x is 0 to x is 1. All right, so let's have a look at what that might be. So this is the graph of f of x equals x cubed minus 3x. So you're asked to go from x is negative 2, which is this point here, all right, here's x is negative 2, to x is negative 1, which is here. So we're going to go from here to here. Now, I'm going to try to draw this freehand, but essentially it's a line that looks like this, almost, kind of. Then you're asked to go from x equals 0 to x equals 1. So here's x equals 0, here's x equals 1, and so now you're going to draw the graph. I missed, but it's something like this. You'll see it again in the next slide or two. But what essentially I'm going to do here is I'm going to figure out what the slope of this line is and what the slope of this line is, and that will tell me what the average rates of change are between those 2 points. So here is the first line that I tried to draw. This point, remember, is negative 2, comma, negative 2. This point up here is negative 1, comma 2. All right, and so if I want to calculate the slope of this, all right, it's going to be 2 minus negative 2. All right, these are the y values, divided by -1 minus -2. Okay, now of course minus a negative is equal to a positive, and so this is going to be 4, and this is going to be -1 plus -1 plus 2. Whoops, -1 plus 2 is 1, and so the slope here is 4. All right, and so the average rate of change for this graph, x cubed minus 3x, between x equals -2 and x equals -1 is 4. Now, in the other graph, I'm going to start at the, actually, I think I started at this point, right? Between 0, 0, 0. X equals 0 to x equals 1, right? So this point is 0, comma 0. This point is 1, comma -2. And if I want to calculate the average rate of change, it's going to be 0 minus -2 over 0 minus 1. That's going to give me 2 over -1, or an average rate of change of -2. Right? And so my for the function f of x equals x cubed minus 3x, between x equals 0 and x equals 1, my average rate of change is -2. All right, so that's, whoops, negative, come on, -2. All right. That, my friends, is where we're going to leave video number 2, and I hope that you learned something.